Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy. This is Suresh, Faculty of Chemistry. How are you all doing? So आज हम चर्चा करना practical organic chemistry in the series of NCERT line by line. So you all done what? Your CBS examination. Now it is time to revamp your preparation for your NEET examination. Now exactly 2 months are there and the last 60 days strategy. So I want to come up with the topic to topic and NCERT line by line for you all as your preparation for the practical organic chemistry. Why I'm emphasizing this? So I have checked the pulse of NTA. So NTA is directly sticking to the CBSE NCERT textbook and already given a big signal that in the January 2026 there are 10 sessions of JEE examination has been conducted. In that, so each and every session one question has come from this practical organic chemistry. From this practical organic chemistry I am expecting you NEET 2026 May 3rd में होने वाला है and you are going to get one question. Dumas method, Kjeldahl method, Carius method, many methods are there. And all techniques today we are going to discuss in a simplified version so that you will be hoping the best in that. Fine my dear students, a thumbs up and fire emoji in the start before, and also I request those who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. So बच्चों अगर कुछ डाउट है तो you can directly ask in the chat box so that we can have the super discussion among us. So let us start. शुरुआत से practical organic chemistry बच्चों. Here first you have two categories: purification, then detection of elements, qualitative analysis, and we can say quantitative analysis. This is purely based on grade 11th one. And one session we will take to the functional group analysis also. That is also very good method for getting things. Cool. So let's see here purification. Purification means the removal of undesired impurities associated with a particular organic compound obtained in the organic chemistry. So you take something, you say leaves you take from the plant and you grind it, some medicinal plant. In that you will be having some kind of the medicinal values. Mean to say there are some chemical compounds, we have to purify that chemical compound ताकि आप इस्तेमाल कर सकते हैं दवा के जैसे. And in that purification you have crystallization. It is based on the principle of solubility, variable solubility. So depend upon the various solute and the solvent interaction का हिसाब से आप ले सकते हैं. And based on the principle of solubility, solutes tend to be more soluble in hot liquids than in cold liquids. So if the saturated solution, hot solution is suddenly cooled, so the crystals of the substance is going to be identified, and these crystals can be further filtered to get the pure compound. This is crystallization. And sugar mixed with common salt can be purified by using ethanol. Differential solvents also can be used. Phthalic acid is mixed with naphthalene. Now you can see these are the things. High license. These are the things. What is phthalic acid? So this is your phthalic acid. You need to know. Everybody knows about the sugar, common salt, but you should know what is phthalic acid. This is your phthalic acid. And what is a naphthalene? Naphthalene is this. And phthalic acid is soluble in hot water. Naphthalene is not. License, I don't understand. Hello, those students who are online, say hi, hello, and give your name. Hashan. Now moving ahead. Yes, naphthalene or napkin. Naphthalene is used in deodorizers and deodorizing the washrooms and all. Okay. Anyways, impure solid is dissolved in solvent. the solution is heated to evaporate most of the solvent, then the hot solution is allowed to cool, the solid appears to pure crystals, and the cooled solution is poured of obtained the crystals and it is evaporated, right? And moving ahead, sublimation. And the substance who can sublimate. What is the meaning of sublimation? Conversion of the solid directly into the gas is called as sublimation. So this sublimation is only done for the substances who can sublimate, like naphthalene you can use, camphor you can use, okay, like this. This process is very useful in the separation of substances, of substance which sublimes on heating non-volatile substances के साथ होगा तो. And I want to say, which of the following can be purified by sublimation? You can use benzoic acid, you can use naphthalene, and you can use anthracene, camphor, indigo, and anthraquinone. In that, benzoic acid is important. Benzoic acid and naphthalene are more important. Conversion of which? Solid to gas. Solid to gas, right? Now moving ahead, these are all the fundamental things. In the sublimation you take the impure mixture and inverted funnel, उसमें cotton plug लगा दो. If you put a cotton plug, it cannot evaporate further away. If you heat it, so the sublimated substance is going to be condensed here. Later on you can take this funnel out and you can scratch this funnel to get the pure substance. This process is called as a sublimation. So of course we are practical oriented and we will discuss about talking about the distillation, and it is a super awesome concept. Distillation, it is used to purify liquids which differ in their boiling points. Okay, so let us say various forms. This is the basic establishment and setup of this distillation, and you can say it is a liquid, and this liquid is heated, so that liquid is getting evaporated, and you can monitor the temperature. You have to keep this bulb of the thermometer exactly here, ताकि आपको पता चलेगा कौन सा temperature में ये liquid condense कर रहा है. And it is coming over here by using a cool water inlet and outlet jacket. You are condensing it, so you are condensing this vapor and connecting to this, you are collecting the condensed water. So this is simple distillation method. In this simple distillation method, we can use many distillations. So I will discuss separately what are the distillation methods and how it is done. And you are evaporating a liquid and you are condensing back as a liquid. So you can play the game over here, and various types of the temperatures and various types of methods can be used, and vapor pressure and boiling point. These two terminologies are very important. What is vapor pressure? The pressure exerted by the vapor on its own liquid at equilibrium is called as vapor pressure. Then what is a boiling point? The temperature at which the vapor pressure is equal to atmospheric pressure, that temperature is called as a boiling point temperature, right? So bacho, and technically you need to understand some terminologies as well, right? So we'll see various types of distillations here: simple distillation, fractional distillation, and distillation under reduced pressure, and a steam distillation, and 4 distillation methods are there. Okay, so what are the methods and how it is done? Let us see. So it is a simple distillation. Simple distillation is a distillation method we can use when the separating liquids has a very good difference, large difference in their boiling point, that can be used for simple distillation. Or liquid has to be separated from non-volatile impurities. So this is another one you can say, right? So I have got one doubt, Messi, Ronaldo. What is your doubt, you tell me? What is your doubt, you tell me? Okay, now let us talk about in this you can say the simple distillation. You have benzene and aniline. If you check their boiling point 80 and 184, काफ़ी ज़्यादा फ़र्क आ रहा है ना. So you can separate the liquid mixtures, and 61 to 84, 184, and you have a large difference in their boiling point. You can use a simple distillation method for this. Okay, Messi or Ronaldo. Okay, I'm Suresh and I'm a chemistry faculty. Or talking about soccer and all, I don't have any. So this is the class which we use to discuss about NEET preparation, chemistry, and the best way I can do that. And moving ahead, fractional distillation. This fractional distillation is very important for separation of liquid mixtures which have narrow and very little difference in their boiling point. You can say it is a fractional distillation. In that, you have a long fractionating column, so that if the liquid has a little difference in their boiling point, let us say liquid A and liquid B, and liquid A and B is also going to rise along with that, but the one which is having less boiling point will go, and the another one relatively having more will come down. So this is how this fractional distillation is done, and as this is distillating, you are going to get this small collections of the receiver flask, that what you can say it is a fractionating column, and this is a fractionating column, and this is going to be a fraction. You understand, when you go for a organic chemistry reaction, let us say SN1, you are going to get a racemic mixture. In that racemic mixture, you have plus isomer as well as a minus isomer and equimolar proportion. So when you distill this racemic mixture, no, this racemic mixture is going to boil together. Why? Because this racemic mixture has enantiomers. Enantiomers have similar physical properties, I mean to say similar boiling point, so that they are going to boil together, they are collected as one fraction only, while the diastereomers as the different physical properties, they can be separated by fractional distillation. So when you see, however, so many stereoisomers can be possible, you can count and tell how many fractions that can be obtained. So you need to have, okay, you need to have a clear picture about how the things are going to happen. You can see example of fractional distillation. Petroleum products are done by this method, and methanol and propanol is done by this method. You can see methanol 65 degrees centigrade and propanone 57 degrees centigrade, and you see the difference between these two, very 8 degrees variation. Benzene and toluene 80 to 110, it is also very close, right? So bacho, Messi or Ronaldo we can do. Next, vacuum distillation. Vacuum distillation can be done in two cases. Either case one, I want to say, if the liquid has a very high boiling point, okay, or otherwise if the liquid is going to decompose before its boiling point. In these two cases, you just say vacuum distillation or distillation under reduced pressure we can do. On reducing the external pressure, liquid will boil at low temperatures. So compounds which decompose at the temperature below their normal boiling point cannot be distilled at atmospheric pressure. You have to decrease it. And you can see, when you connect a vacuum pump over here, you are going to decrease the boiling point, so that the boiling point physically it is decreased, and you are going to get that distillation under reduced pressure. And NCERT very good question is given. So vacuum distillation, glycerin can be distilled at 180 degrees centigrade lower pressure. So this is the terminology NCERT में सीधा दिया NCERT. Separation of glycerol from the spent lye in the soap industry is done by using vacuum distillation or distillation under reduced pressure, and the same statement is asked several times in various levels of competitive examination. Now you can get the same statement. Spent lye mean to say soap industry mein you are going to use a fat and a glycerin and a alkali during saponification, and the soap is prepared and unused glycerol is separated by this vacuum distillation or distillation under reduced pressure. अगर कुछ doubt है ना तो जल्दी पूछो. Those students who are online, please like the session, and expecting you to give the questions so that I am ready to. Yeah, what is spent lye? The spent lye, I told you, no, how you prepare in the soap. So you just say fat, glycerol and the sodium hydroxide. Okay, fat and excess of glycerol is added. You know Pierre's soap. This is a glycerin soap, you can say. Now, once this fat saponification होगा तो excess glycerol बचा है ना, so that is that overall process completed. You are going to get excess glycerol and a soap is going to be left. Okay, that is called spent lye. In that spent lye, glycerol is removed, soap will be separated. You can add some colors, you can add some perfume and make into a shape and wrap it, pack it and you sell it. Soap industry hai. You understand? Clear? That's good. Now you ask, then only we will understand what is our route. Now moving ahead, like steam distillation. So steam distillation, the liquid boils when the sum of the vapor pressure due to organic liquid is due to water is equal to atmospheric pressure. So I mean to say steam distillation, this process is used whenever the products that are formed, which can form intramolecular hydrogen bonding and intermolecular hydrogen bonding. So I want to say here, phenol, when the phenol is treated with dilute HNO3, so when you treat with dilute HNO3, you are going to get orthonitrophenol and paranitrophenol as an isomer. So this is the same technique, you can connect here and there. So orthonitrophenol, if you check the structure orthonitrophenol ka, you are going to get intramolecular hydrogen bonding. So it is steam volatile. Steam volatile mean to say it is going to be evaporated along with the steam. So like that, orthonitrobenzaldehyde, para-nitrobenzaldehyde can be done. This is orthonitrophenol, right? Now, this is the steam distillation establishment setup here. You are going to just boil it and collect the vapors. But the thing is, you are going to take the water boiled and the steam is percolated through it. When the steam is percolated through it, along with the steam, the vapors are condensed here. In that vapors, you are going to get the distilled liquid along with water is collected here. So you can separate this water and you can separate this liquid by differential extraction. Now, so differential extraction, it is the process of separation of organic compound from the aqueous layer and the non-aqueous layer by using organic solvent. You use the simple method. So aqueous is soluble, the water soluble thing, in water insoluble thing are organic soluble. In that you can say, yes, this is the one, you have organic compound with aqueous layer, organic solvent layer. You just shake the liquid with it, the organic compound in the solvent layer is separated, aqueous layer is separated, and you can open the tap and you can collect it, and you can collect it from here, right? Fine. Now chromatography. So chromatography is a technique. It is a super awesome technique, you can say. It is used to purify, and you can use it to detect, you can use it to quantify and characterize the organic compound. The most sophisticated technique that we use in the chemistry. So far, any chemical industries, any pharmaceutical industries use chromatography as the chief technique, for the main technique for their assessments and all. And vacho, based on this chromatography, you have various types of chromatography is there, and separation of compound of mixtures takes place as a result of differential adsorption on the adsorption column. You have two types of chromatography basically, and partition chromatography and adsorption chromatography. After separation, the substances are extracted from the adsorbent using a suitable solvent, which is called eluent. You have effluent and eluent. Effluent is different, eluent is different. We use eluent in the chromatograph language, okay? And you have adsorption, so accumulation of a substance on its surface, okay, more on the surface, not in the bulk of the body, is called as adsorption, okay? And we use chromatography. So based upon differential adsorption of various components, the mixture suitable adsorbent, some compounds are more strongly adsorbed, some compounds are less strongly adsorbed. So if you just add some solvent, the one which is less strongly adsorbed can be released out, and you can get the product and collected like this. Chromatography, you have adsorption chromatography and you have partition chromatography. Bacho, in the adsorption chromatography, you have column chromatography, you have thin layer chromatography, while partition chromatography, you have paper chromatography. Bacho, so this is the basic classification of the chromatography. So moving ahead here, column chromatography. In the column chromatography, you will be having a chromatography column like this. आपको थोड़ा सा burette के जैसे होता है, right? A mixture is placed on the top of an adsorbent column packed with a glass tube, right? So in that you will be having some silica or alumina is packed. So in that mixture of compounds will be added here. So an appropriate eluent, I want to say here a mixture of compounds ABC is added. In that you have ABC, and a liquid solution is added from here with the differential polarities. So along with the liquid, ABC is going to be getting down based on that, and you can collect it. That is how column chromatography is done. And you can see it involves in the separation of components of mixture over a thin layer. This is our the thin layer chromatography, TLC. In this thin layer of chromatography, a thin layer of adsorbent silica gel is spread over thin glass plate, and the glass plate is known as TLC plate or chromatogram or chromatograph. And you can see this is your thin layer chromatography. So this is a plate on which the sample spot is done, and this is a solvent. So solvent is going to creep up, solvent is going to creep up here. So along with that, the compounds present here are also going to move and separated like this. And you can calculate the RF factor, retardation factor like this. This is how you are going to separate it. And you can also say this is a chromatography, and the spot is made here, different compounds are being separated, and up to here. So this is a TLC chamber, this is your mobile phase, this is your stationary phase. TLC plate itself is a stationary phase, and the liquid is moving up, that is called a mobile phase. And I want to say, thin layer chromatography, this is a very important point, RF factor, otherwise retardation factor. It is the ratio of distance moved by the component from the baseline upon distance moved by the solvent. Okay, and based on this RF values, the components are being separated. And also partition chromatography, it is a paper chromatography. It is based on continuous differential partitioning of the components of a mixture between the stationary and the mobile phase. It is a paper chromatography. In that you can say, so principle of paper chromatography is a partition chromatography, whereas in the substances are distributed partitioned between the liquid phase and the stationary phase. So between the liquid phase and the stationary phase, the migration of these solutes are going to be taken place. Okay, Bacho, please ask doubts. Now let us see, this is how the paper chromatography is done, just like a thin layer chromatography. And once this is separated, this is the chromatogram, you can see. So this is the baseline, and this is what is called the solvent moved. So that is called solvent front, and this is the distance traveled by A, this is the distance traveled by C, distance traveled by B, like that you can say, right? Overall board examination, congratulations, Anuj Gope, Pyar se Madhya Pradesh. How are you? Now let us see. So column chromatography, I already explained, this is how the column chromatography setup is seen. So Anuj, एक बार like मारो session में, and you have different partitions are seen. All, how did you do your board examination, बच्चों? How did you do your board examination? Beto is there in today's class? Okay, still boards are going on. Now you can say, so qualitative analysis and quantitative analysis. So analysis, so far we extracted and we analyze it. So in this you are going to have very good questions, bacho. So identification of elements present in organic compound, detection of elements, you can go for carbon and hydrogen, nitrogen, sulphur, halogens and phosphorus. Okay, various compounds or various elements can be detected in this way. So carbon and hydrogen is done by using a organic compound. I am depressed now due to car. Why? Why CAR? So it is passed through. Carbon is detected by heating the compound with the copper 2 oxide. So that copper 2 oxide, carbon is converted into carbon dioxide. This carbon dioxide is going to turn lime water milky. So whenever lime water milky is turned, we can say turbidity is seen, we can say the carbon is present. Whenever carbon and hydrogen are there, organic compound must contain carbon and hydrogen. And hydrogen of the compound is converted into water, so that water vapor is passed through anhydrous copper sulfate. So that anhydrous copper sulfate is going to turn blue in color. So turning of the white to blue color of the copper sulfate can tell you it is hydrogen is present. Seriously, why, what happened, Anuj? After board examination, you have to focus on the competitive examinations, isn't it? And yeah, organic compound, copper, carbon and hydrogen. So carbon is converted into carbon dioxide. Detection of carbon dioxide done by using lime water turns milky. Organic compound, hydrogen is converted into water. This hydrogen is water is converting white copper sulfate to blue. White copper sulfate to blue. Are you getting or not? Clear? Now let us talk about all the Lassaigne test. Detection of nitrogen, phosphorus, sulfur and halogens. It is done by using Lassaigne test. MHT, yes. Okay. Why? Why you are nervous about that? Seriously? Focus, stay focused. If any help is there, Sonali Gope is actually Anuj Gope. Any examination, if we have any issue, you just share with me and I am going to give you the best remedy of the proper guidance motivation. Actually, the detection of these elements is difficult because carbon to the bond with these elements is covalent. When we make these covalent compounds to ionic, it is going to be detected by using simple inorganic test, right? So this is how carbon and nitrogen react with sodium to give rise NaCN. Sulfur is going to react, gives Na2X. Halogen is going to give rise NaX, and if carbon, nitrogen, sulfur is there, NaSCN is formed, right? Beta, fine. Now this is how you see detection of carbon, nitrogen, sulfur, halogen is done by using a Lassaigne test. This Lassaigne test is done by using Lassaigne extract. Piece of sodium in organic sample is directly heated to red hot in a small test tube called ignition tube, and it is plunged into the water, and it is automatically broken when you plunge it into the water in the red hot condition, and you just grind it and boil it and extract it, and it is filtered, and this is what is called as Lassaigne extract. In that Lassaigne extract, you can say various reactions. You can say Lassaigne test and sodium fusion extract. In the sodium fusion extract, detection of nitrogen. In this detection of nitrogen, जो reactions आपको दिखाई दे रहे हैं ना, वो काफ़ी important है. नीट एग्जामिनेशन में सीधा क्वेश्चन आने को संभावना भी है. Okay, so I am telling you, it is Lassaigne extract is added with FeSO4, and you are going to get sodium hexacyanoferrate too. It is called as a Prussian blue. Okay, on heating with sulfuric acid, some Fe2 plus ion oxidizes to Fe3 plus ion. This is what is called as a Prussian blue. And in that, no, this is not Prussian blue. And to that, little Fe3 plus is formed. Now this little Fe3 plus is going to form a complexation Fe4 FaCN6. Okay, this is what is called Prussian blue. The complex Prussian blue का structure भी काफ़ी important में. Which of the following is the formula of the Prussian blue will be asked in the examination. You have to be very conscious about this, and you can ask is, so how to remember all the reactions SONA unique. So that's what we require. That's what we require our efforts in that. When you prepare and when you organize it, automatically you can remember. So when you sit all of a sudden and you by heart, you don't remember, right? So let us see. This is how a Prussian blue will be visible to you. All the things I wanted to show you, right? That's a good question. You just follow the same methods. So आगे आपको organic reactions भी देना चाहता हूँ. Okay, and you see, you like it Prussian blue कैसे, right? And one more, and detection of sulfur, you can have a lead acetate test and sodium nitroprusside test. And in this, I like this test, sodium nitroprusside test. Sodium fusion extract is acidified with acetic acid and lead acetate is added to it. So Na2S, this is extract. To that lead acetate is added, you are going to get lead sulfate, and this lead sulfate is black precipitate. Appearance of this black precipitate indicates its sulfur is present, and and this black precipitate indicates the presence of the sulfur. And also you have nitroprusside test. This nitroprusside test, Na2FeCN5NO, and this is converted into a violet, Na4FeCN5NOS. So appearance of this violet indicates the presence of sulfur, right? So this is what is called a sodium nitroprusside. So we have seen nitrogen is there, sulfur is there. Now, so this is how sodium nitroprusside violet color is seen. This is a violet color. Now, if both nitrogen and sulfur is present in the organic compound, looks so it is complicated, but it is so easy. And sodium fusion extract is containing sulfur NaSCN. To that, simply FeCl3 is added, neutral FeCl3 is added. So, you are going to get blood red color complex. So, appearance of this blood red color indicates both sulfur and nitrogen is present. Okay. Now, this is how this test is done. So, this is a YouTube studio. I am ready and I am trying my level best to show how the experiment is done. Always visual examples are very important and you can do the best. If you have any doubts, those students are online, please you can ask. Does this add with ferrous sulfate? No, no, no. Nivesh, it is not with ferrous sulfate, it is with neutral FeCl3. Should be so cautious about this reaction, how it is classified in various ways, right? Let us go with the detection of halogens. When you detect with halogen, you add silver nitrate. But this silver nitrate is going to react with not only halogens but also interfere with cyanides. So, cyanide Cn minus sulfide S2 minus of the sodium fusion extract is interfering. So, that the sodium fusion extract is first boiled with concentrated nitric acid. So, that cyanide will be converted into HCl, which can be expelled out. S2 minus will be converted into H2S, which can be expelled out. So, that the reasoning, assertion and the reasoning type questions are very, very, very important. So, moving ahead, how this Lassaigne test is done. Sodium chloride is formed as a Lassaigne extract if chlorine is present, if bromine is present, NaBr, NaI if iodine is present. When you add a bit of sodium AgNO3, you are going to get white precipitate, and it indicates a white precipitate of AgCl, and it is soluble in ammonium hydroxide. So, indicates the chloride is present. If it is pale yellow precipitate, partially soluble in ammonium hydroxide, indicates the bromine is present. If AgI yellow precipitate is there and it is insoluble in ammonium hydroxide. Fine. This is important when you go for examination point of view, bachcho. And this is how a pale yellow, white, pale yellow, and it is yellow. So these are on white. All of a sudden you can see, and you can't say it is a yellow. So that solubility is the perfect benchmark to say whether it is AgCl AgBr, and it is going to be AgI. Fine. NAF does not give this test. Whenever the fluorine is present in the organic compound, in the inorganic compound, reactions of fluorine is completely different. We don't study in the systematic way. Okay, completely different. We don't have that. When it forms, it is AgF is going to form. AgF is ionic, it don't form the precipitate. You are asked a good question, why you are retracting the messages. This is AgCl is a precipitate. When you talk about AgF is ionic, soluble, it is not precipitate. Fine. Now moving ahead, test for phosphorus. Test for phosphorus. Compound is heated with oxidizing agent like sodium superoxide, and phosphorus present in gets oxidized to phosphate, and the solution is boiled with nitric acid, then treated with ammonium molybdate, and it gives yellow coloration of precipitate, indicates the presence of phosphorus. So the yellow color, what is the compound? Phosphoammonium molybdate. So this is what is called canary yellow. Now this is how phosphorus compound present in this as formed as a phosphate, and it is boiled with HNO3 gives rise. The phosphate is converted into H3PO4. This H3PO4 is treated with ammonium molybdate to give rise yellow precipitate. The formation of this yellow precipitate indicates it is phosphorus is present. Okay, betam. This is how the yellow precipitate is seen. Bacho, any doubts? Now, in the quantitative analysis, quickly we will see carbon and hydrogen estimated, nitrogen estimated, sulphur and halogen, phosphorus is estimated. So, in one shot, I wanted to complete this. Continuous cough is coming. I request my students, please excuse me. Okay. So, as students are expected classes with us, and we are giving the best, and of course we are not well, I don't want to just stop the class. Let me complete this. How this carbon and hydrogen is present. As we know, carbon and hydrogen present in the compound, we are going to get with copper oxide, so that carbon dioxide and water is formed. You just take the mass of, collect the carbon dioxide and you just identify, and the mass of water is taken, and based on that carbon dioxide is absorbed in the potash bulb, mean to say potassium hydroxide, and water is adsorbed on calcium chloride bulb. So that you just take this bulb, anhydrous calcium chloride, it gives rise the mass of the water, and potash bulb gives the mass of carbon dioxide, and these masses of these bulbs are weighed and estimated carbon. You have a formula, estimation of carbon is equal to 12 by 44 into mass of carbon dioxide into upon mass of organic compound into 100, and percentage of hydrogen is calculated as 2 by 18 into mass of water upon mass of organic compound into 100. So you can directly use the formulas, you can get the answers, right, bacho? And also estimation of nitrogen is done by using Dumas method. It is done by using Kjeldahl method. In the Dumas method, the nitrogen is estimated by using converting into nitrogen gas. In the Kjeldahl method, nitrogen is estimated by using ammonia gas, it converting into ammonia gas. So carbon is converted into nitrogen, is converted into nitrogen gas. And then nitrogen gas is estimated by using the formula. Nitrogen is collected over the concentrated solution of potassium hydroxide, because carbon has to be absorbed on that. So this is how it is done. Carbon dioxide is passed and the compound is heated in a furnace, so that nitrogen is collected over here. So based on this amount of nitrogen, volume of nitrogen is collected at STP, and percentage of nitrogen is equal to 28 by 22400 into volume of nitrogen at STP upon mass of the organic compound into 100. So this volume of nitrogen milliliter में लेना, क्योंकि ये 22400 लिया था ना. Dumas method 4 times it is asked in 2026 JEE examination. Talking about here, we'll do it later, we collect it, okay. Kjeldahl method. First, let us complete the concepts, right? And in the Kjeldahl method, the organic compound is digested with concentrated H2SO4, so that it is going to be converted into ammonium sulfate, and this ammonium sulfate is decomposed to get the ammonia, and that ammonia is trapped and estimated, so that amount of ammonia that you got is directly equivalent to the nitrogen present in it. So this is how Kjeldahl preparation. So this is called Kjeldahlization. First it is digested with concentrated H2SO4 copper sulfate, and the Kjeldahl extract is boiled along with a Kjeldahl flask after digestion, boiled along with sodium hydroxide. By using this, ammonia is observed, so that you are going to know the substance, the compound which is decomposed, and this known volume of standard acid से आपका estimate कर सकता. Now the resulting acid mixture, the organic compound H2SO4 ammonium sulfate is decomposed to get ammonia, right? And that ammonia is trapped. Amount of ammonia is produced determined by the estimation of amount of sulfuric acid consumed in the reaction. The acid left unused is estimated by titration with some standard alkali. And the method is not applicable, very, very important, if the organic compound is contain nitro group, azo group, and if the nitrogen is present as a part of a ring. So this is not used for Kjeldahl estimation. So according to Indian Pharmacopoeia, the nitrogen is estimated in the protein by using Kjeldahl method only, right? Now you can use simple percentage of nitrogen by using Kjeldahl method is equal to 14 into normality of the acid, volume of the acid upon 1000 upon into weight of the organic compound into 100. So this is the simple formula that you can use directly to calculate the percentage of the Kjeldahl method. Actually Kjeldahl method is a long process, okay. Overnight you have to stay in the laboratory. So but we don't see and we don't use and we don't do as well, but we will do questions based on this Kjeldahl method, right? Now we have estimation, wait, let me explain all this. Estimation of sulfur. So the estimation of sulfur is done by using by converting sulfur present in the compound as a barium sulfate, right? So this barium sulfate, we have to take a long Carius tube. In that the organic compound is digested with HNO3, then you can add with barium chloride, so that sulfur is going to be digested as a barium sulfate. You just take this barium sulfate here and estimate the barium sulfate, how much it is there. The percentage of sulfur directly you can say 32 by 233 into mass of the barium sulfate upon mass of the organic compound into 100. You can directly use this. Right? And very limited number of formulas are there. You can use the formula, you can do that. But based on this practical organic chemistry, 2026 May 3rd, one question will be there, the same recording you can replay it. I can say based on estimation of sulfur, estimation of phosphorus, estimation of nitrogen, 2026 NEET examination on May 3rd, in the same studio we are going to discuss the paper, you are going to get the question. And Carius method. So in this Carius method, the organic compound is mixed with HNO3 and AgNO3, and you just heat it for a long time, okay. And for this estimation of halogens can be done. So chlorine is trapped as a silver chloride, and bromine is trapped as a silver bromide, and iodine is trapped as silver iodide. And the mass of the precipitates are collected, and you can see this. And it is the percentage of chlorine is 35.5 upon 143.5 into weight of silver chloride upon weight of organic compound into 100. Similarly, for the bromine, you can see for the bromine, percentage of bromine 80 by 188 into weight of silver bromide upon weight of organic compound into 100. So in one session, in one shot, all the formulas are being given. Just take use of this. Those students who are online, please like the session, and you ask any doubt, and we watch the recording, and you can just explore the things, and you can post in the comment as well, we can discuss it. And also estimation of iodine. So 127 upon 235 into weight of silver iodide upon weight of organic compound into 100. So like that we do the halogen estimation, okay. But so we can see estimation of phosphorus you can do by using this method. Phosphorus present in this organic compound is treated with magnesium. This magnesia is going to make this phosphoric acid to magnesium ammonium phosphate precipitate. When you heat it and dry it, you are going to get magnesium pyrophosphate Mg2P2O7, and based on that you can calculate this magnesium pyrophosphate mass, and based on this magnesium pyrophosphate you can just simply use this formula and you can estimate the thing. And ऑक्सीजन करने के लिए कुछ अलग फॉर्मूला नहीं होगा बेटा. सो ऑक्सीजन इज डन, percentage of oxygen is equal to 100 minus the sum of the all elements, right beta. Now I think we are done with all those methods, and सिर्फ न्यूमेरिकल करने को और टाइम लगेगा, but time is limited here. So बच्चों, today we discussed about okay purification methods and detection of elements and estimation of the elements, and all qualitative methods we have done. In that Dumas method, Carius method is very important, okay. So Kjeldahl method is a little complicated, but I made it simple. And next session we are going to talk about practical organic chemistry में functional group के analysis कैसा कर सकता हूँ. Definitely these two areas where you are going to get a question. So please like this session. I am done from my side. Okay, signing off, Suresh, Faculty of Chemistry from Sri Chaitanya Academy Infinite Talent YouTube channel, and stay tuned to the channel so that we'll be having so many better sessions for your better rank. Thank you. God bless you.